sorry, in the last period we talked about picturing motion. We started our lesson by defining what's the meaning of motion, types of motion. Today we'll talk about how can we represent motion. How can you study motion? We have many models. We have many ways to study motion. Okay, but before we start, just I want someone to remind us about the meaning of motion and another one is the types of motion. So what is the meaning of motion? Who can remind us what is the meaning of motion? Abdulaziz.
Yes, Mustafa. Motion is when an object or a person changes its over time.
It changes its position over time. Excellent, Abdulaziz. Thanks a lot. Muhammad Hilal Sumbul. Okay, Muhammad. Types of motion. Muhammad. Types of
Types of
motion.
motion, there are four types of motion.
Yes.
First is the linear motion, then the rotational motion, the periodic motion, and the circular motion.
Excellent, excellent, Muhammad. Thanks a lot. Okay, Shabab. I want another one to give us example for linear motion. Example for linear motion. Aziz and somebody can do Okay, Ryan وباشا.
Like moving from point A to B, like from Jeddah to Mecca through a
Yes,
plane.
moving in straight lines. Okay, thanks, thanks. Okay, Abdulaziz Faiz. Abdulaziz Faiz. Can mute yourself, يا Abdulaziz. Abdulaziz Faiz الفتني. Abdulaziz, are you here, يا Aziz? Where are you, Abdulaziz? Okay, Manaf, give us another example.
About periodic, mister.
Okay,
Like Earth rotating around Sun.
Earth rotating
Around the Sun.
the Sun. Yes, Earth rotating around the Sun. Okay, so it is what? Rotational.
Periodic.
Okay, you have to say when you are talking about periodic, you have to say that the Earth repeats its motion around the
Its
Sun
motion.
at the same time. At the same time.
Time.
Okay, because we have also a circular motion. When the Earth revolve around the Sun, we consider it circular motion. But if we said that this is a repeated motion in equal time intervals, okay, every 1 year, so we are talking about periodic motion. Okay, so periodic motion
Okay.
is related to time, related to time. Okay, thanks. Faris, Farid, Faris.
Yes, Mr. Rotational motion. Rotational motion rotate around itself,
When the Earth
around its axis.
rotates around its own axis or about itself. Okay, excellent, excellent. Okay, thanks, Safar. We still have, I think we said linear, circular, okay, periodic, and now we say rotational motion. Okay, thank you, guys. This shows the meaning of motion and the types of motion with examples. Okay. Then also we talked about what are the factors. This question, I said identify two factors you must know in order to describe the motion of an object along a straight line. Who can answer this question? Let us see. More different persons. Abdul Karim. Abdul Karim. Ayman. Shabab, I'll take attendance. Tell your friends, WhatsApp them or send them a text message that I'll take attendance through mic. I'll take attendance through mic. So if you are not here, it is not enough to sign in and leave your account. Okay, so I'll check attendance Roman. So now I called Faris, he is not here. I called Abdul Karim, he also is not here. Okay, Ahmed Bajaba. Ahmed Bajaba.
Yes, Mister.
Yes, Ahmed. Can you answer this question? We said to identify motion, we need two factors. What are these two factors? An object is moving. How you know? How can you identify the motion using two factors? What are these two factors? We answer the same question. Mm.
I don't know, Mister.
Look here, the description of motion is a description of place and time.
Time.
Okay, so you must answer the questions of where an object is located and when. So you can ask a question by where and when. Where is about the position, where is about what? Position, and when is about time. So what are the two factors that we use to identify motion? And position and time. Position and
Time.
I hope it's clear. Okay, thanks, Ahmed. You can mute yourself. Okay. So now we'll talk about how can we represent motion. Like here, look to this runner. Okay, she is running. She started from left of the tree. Okay, and she will go to the right side according to my view. Okay. There is someone wants to enter the room with Aziz, and I think don't tell Ali. Okay, so here you can see that how can you tell that this girl is running or is in motion? Who can answer this question? How can you tell she is moving? How can you tell that she is moving? Somebody? How can you tell that she is moving?
You can tell she's moving because her position relative to the tree is changing.
Excellent. Can you see here? There is the first position here. If you use the tree, so you must use a reference. What is reference? Something to use to judge about. So is the first position from the tree. Okay. Then here the second position. So the distance between here and the tree becomes less. Okay. So it is moving towards the tree. Okay, how can you tell this? Because the position or her position changes. So as we also we define the motion. What is the meaning of motion? A change in position of an object. A change in position. So if we apply the same definition for the girl is moving or in motion because its position is changing. Relative to what? You can use the lake. You can, but there is here a good reference, which is the tree. Okay, because she is moving toward the tree, or her position toward the tree is changing. Also, you can see here, she passed across the tree. She passed the tree. Okay. Also here, if you continue down, okay, her position what changed also. This is the here position here. Then the position here also what it changed, right? So how can you tell an object is moving? When its position what change? When its position it change. Okay. Now we want to represent motion. This is the first way to represent motion. We can see pictures, right? We can see what pictures. So we can take successive pictures. Yani picture the same pictures at once. They are moving one by one. It's picture number 1, 2, 3, 4. So they are successive what pictures come after each other, that come after each other. Okay, so the first model we can use to represent motion is what? using a picture. And this model, we call it motion diagram. We call it what, shabab? Motion diagram. So this is the motion diagram. You can watch a video about motion diagram here.
Consider an example of straight line motion. A runner running in a straight line. One way of representing the motion of the runner is to create a series of images showing her different positions at equal time intervals. Notice that the runner is in a different position in each image, but everything in the background remains in the same position. This means that relative to the ground, only the runner is in motion. A series of images showing the positions of the runner at equal time intervals is called a motion diagram. A particle model is a simplified version of a motion intervals is called a motion diagram.
Yes, so here you can see a series of images showing the positions of the runner or of the moving object at equal time intervals is called a motion diagram. It's called what? A motion diagram. Okay, so this is the meaning of motion diagram. So we use a series of images to show the different positions of the moving object at different time intervals, or at equal time intervals. What is the meaning of equal time intervals? It means I am measuring. I can consider taking its position every 1 second or every 1 minute. So if you have a watch, you can measure or detect its position after 1 minute. You count 1 minute and detect its position. Then pass 1 minute and take its position. Then pass 1 minute and takes its position, and so on. So this is the meaning of equal time intervals. It means you will capture its position at the same time every once, okay, or every time. Okay. So back here to our book. Do you have any questions about motion diagram? If you have any question, raise your hands. Do you have any question? If you have any question about motion diagram, we use motion diagram to represent what? Motion. Do you have any questions? Okay. I want someone again to explain for us what is the meaning of motion diagram. Yusuf Gaber. Yusuf Gaber. Yusuf Jaber. Are you here, Yusuf? Yusuf Gaber means you are not here. Yusuf Gaber, you are not here, Yusuf. Okay, Yusuf Idris. Yusuf Idris.
Yes, Mr.
Yeah, what do you
The
explain?
motion diagrams is a series of images showing the runner's position at equal time intervals.
Yes, okay. Can you explain in your own words what does it mean? In a simple words.
I can't.
You can't? Why you can't? Explain the meaning. Imagine that you have your little brother, you are explaining him what's the meaning of motion diagram. You are taking pictures, right?
Yes.
For the moving object.
Yes, for the moving object.
Each 1 minute or each 1 hour or each 1 second. Okay? It's a very simple way. Okay, understand?
Yes,
Okay.
I know.
Okay, thanks. Yes. So I want someone to read this page, Shabab. This page, I want someone to read. Koshi. Koshi.
Yes, Mr. Okay. Motion diagrams. Consider the following example of a straight line motion. A runner jogs along a straight path. One way of representing the runner's motion is to create a series of images showing the runner's position at equal time intervals. You can do this by photographing the runner in motion to obtain a sequence of pictures. Each photograph will show the runner at a point that is further along the straight path.
Yes,
I
continue.
complete?
Yes.
Okay. Consecutive images. Suppose you point a camera in a direction and the runner crosses the camera field of view. Then you take a series of photographs of the runner at equal time intervals without moving the camera. Figure 2 shows what a series of consecutive images for a runner might look like. Notice that the runner is in a different position in each image, but everything in the background remains the same position. This indicates that relative to the camera on the ground, only the runner is in motion.
Okay. So you are using a reference. What's the meaning of reference? And something you are using to judge if the position of this girl is changing or not. For example, here we choose the reference as what? The tree as a reference. We use the tree as a reference. Why the tree? Because we know the tree has a fixed position. Okay. The girl started from many points. Okay, and she is changing its position from the tree. So we use the tree. She is moving relative to the tree, or when we use the tree as a reference. Okay. If we move to the next page, combining images. I want another one to read. This one. Combining images. Okay, so
Yes, yes, Mr.
yes, please read this one.
Yes. So combining images. Suppose that you layered the 4 images of the runner from figure 2, one on top of the other. Figure 3 shows what such a layered image might look like. You see more than one image of the moving runner, but you see only a single image of the tree and other motionless objects in the background. A series of images showing the positions of a moving object at equal time intervals is called a motion diagram.
Yes, and this is the definition of motion diagram. Okay, and what does it mean? So a series of images showing the positions of a motion diagram. Those the positions of a moving object at equal time intervals is called what, Shabab? Motion diagram. It's called motion diagram. Okay.
Diagram.
Okay, thanks, Yasser. You are Muhammad Saud, right? Or Saud Al-Hamdi?
Saud Al-Ghamdi, Saud Al-Ghamdi.
Saud Al-Hamdi, sorry. Your voice like Muhammad Saud. Okay. Okay. Okay, Muhammad Khayyat. You want to ask Muhammad or to read? Okay, Muhammad will be the next one. Okay, take Muhammad Khayyat. Yes, Muhammad.
السلام عليكم.
Alaikum salam.
I want to read يا مستر.
Okay, next one, inshallah. We'll continue. Okay, so this is the meaning of motion diagram. But here's the question comes: is this way is a practical way? This is a practical way to take pictures, to study motion. It can tell you if you have different objects. We have maybe smaller object moving, maybe bigger object is moving. Okay, this is considered to be a practical way, or we can have a better way than this one. Who can answer this question? Is a practical way, Ryan?
No, I think this is not practical and scientific
Yes,
way of
we cannot study every motion by taking pictures, right, or images of the moving object. Okay,
yes.
it will not give us a clear clues about the time and position. Okay, so scientists thought about another model that will be more practical. Okay, so they thought about what? About a particle, what? About particle models, about particle model. So particle model is based on motion diagram, based on motion diagram. How this one? Here they replaced the object, here the moving object, right? Okay, they replaced this object with what? With dots, with simple dots here. So particle model is talking about replacing the moving object with simple dots. So when you are seeing these dots what? We replace this girl, whatever. It's a girl, it's a car, a dog, okay, a plane, or any object that is moving, maybe electron, maybe very small or tiny particles, okay? So we can replace the object by dots, okay? So we can save a lot of papers using a lot of things we are using by replacing the object using what? Dots, okay? This is the idea of particle model. I think it's a very simple idea. And here, watch this video again. The second half is talking about the particle model.
Consider an example of straight line motion. A runner running in a straight line. One way of representing the motion of the runner is to create a series of images showing her different positions at equal time intervals. Notice that the runner is in a different position in each image, but everything in the background remains in the same position. This means that relative to the ground, only the runner is in motion. A series of images showing the positions of the runner at equal time intervals is called a motion diagram. A particle model is a simplified version of a motion diagram in which the runner in motion is replaced by a series of single points. The size of the object must be much less than the distance it moves. If you see the bottom part of the animation, it shows the particle model for the runner's motion. You can see that applying the particle model produces a simplified version of the motion diagram. Of the runner at equal time intervals is called a motion diagram. A particle model is a simplified version of a motion diagram in which the runner in motion is replaced by a series of single points. The size of the object must be much less than the distance it moves. If you see the model is a simplified.
So as you can see here, that a particle model is a simplified version of a motion diagram. So it is based on motion diagram in which the object or the runner here in motion is replaced by a series of single points, And there is a condition for particle model that the size of the moving object, okay,
in motion is replaced by a series of single points. The size of the object must.
Yes, the size of the object must be much less than the distance it moves. Don't take an image of this runner, okay, bigger than the distance between these 2 points. This is the distance he moved. He moved this distance, right? He moved this distance. He moved this distance, okay. Then this one. So the size of this runner, this one, must be less than the distance he moved. Don't draw him big or something like this one. Okay. So this is the idea of motion of particle model. I think it's very easy.
The particle model for the runner's motion. You can see that applying the particle model produces a simplified version of the motion diagram.
Okay. محمد خياط. Raise your hand, Muhammad, to see you. Muhammad Khayat. Yes, Muhammad, you can read now. Particle models.
Yes.
Read them.
Particle models.
Yes.
Particle models. Keeping track of the runner's motion is easier if you disregard the movement of her arms and her legs and instead concentrate on a single point at the center of her body. In effect, you can disregard the fact that the runner has size and imagine that she is a very small object located precisely at the central point. In a particle model, you replace the object or the objects of interest with single points. Use of the particle model is common throughout the study of physics. To use the particle model, the object's size must be much less than the distance it moves. The object's internal motions, such as the way the runner's arms or the movement of her legs, are ignored in the particle model. In the photographic motion diagram, you could identify one central point on the runner, such as a point centered at her waistline, and draw a dot at its position at different times. The bottom of figure 3 shows the particle model for the runner's motion. In the next section, you will learn how to create and use a motion diagram that shows how far an object moved and how much time it took to move that far.
Okay, thanks, Ahmed. So here, Shabab, you can only highlight the definition of particle model. Okay. So in a particle model, you replace the object or objects of interest with what? With single point. So only. So now you have to know only the definition of motion diagram and the definition of particle model. Okay, so if we revise this lesson fast, we know the meaning of motion. Okay, we talked about motion, then we talked about what are factors that we use to identify motion. Okay, what factors you use to identify motion, and also we talked about the types of motion. Then now we talked about that models we can use. Okay, models that we can use to represent motion. We said number one is motion diagram, and the second model is what? Is a particle model. Particle model. Okay, so this is the 4 main points of the lesson. What is the meaning of motion? Okay, we said motion, when an object changes its position, we consider it in motion. What are the two factors? That affect or control the motion of the object? Said it is what? Time and position. We said what are types of motion? We said we have mainly 4 types. Number one, linear motion. Okay, linear motion, and that is when for the linear motion, when an object moves in a straight line, so it is what? Linear motion. When an object moves in a circle or make U-turn, like when the car making U-turn, it is what? Circular motion, when the Earth orbit around the Sun. Okay. Then we have rotational motion, when like Earth orbiting around itself or around its own axis. Okay, then we have periodic motion. Periodic motion is like the wave motion of the sea, like wave motion. Okay, and also like when the Earth orbits the Sun, the same example, but when you talk about periodic, you have to mention time. So Earth is repeating its motion around the Sun each 1 year, so it is at the same equal time intervals. Also, the Earth repeats its motion around itself, okay, each 1 day, 24 hours. So we consider also what? Periodic motion. Then we came to the models that we can use to represent motion. We said the first model is motion diagram. We said motion diagram is a series of images that represents the position of the moving object, like this runner. Then we talked about the particle model. We said particle model based on motion diagram. How? We replace the object of interest, is the object of interest now, what we care about now, the motion of the girl. So we replace the object we replaced is a girl with what? Simple dots or single dots or single points. Okay, so this means what? Particle model. Particle model. Inshallah, from the first week, everyone, next week, you have to be sure that you have the McGraw-Hill account, because I'm going to give you the codes for your classes. And so you will have an assignment for your classes. Okay, I hope it is clear. So make sure you have your username and password for connected McGraw-Hill. Okay, if we come to physics here for McGraw-Hill, we are in chapter 2, section 1. I said before, from here you can choose the chapter, and from here you can choose the lesson. Okay, you can move here between resources. If we use this check one, it is online course. Okay, you have here section self-check. You can test yourself. Okay, question number 1, who will answer the question? Raise your hands. And question number 2 and 3 and so on. Anas Sharif.
Hello, sir.
Yes, Anas, how are you doing?
What must you be able to answer to describe an object motion? When and where? C.
Okay, so what must you be able to answer to describe an object motion? When and where?
C.
So the answer is C. Okay, thanks. Next question, Shabab. Next question. I want to answer. Okay, Sambo. Question number 2.
Okay. An object can change position along the path of all of these except dotted line.
An object can change position along the path of all these except
Dotted line.
Dotted line? Why dotted line?
Because it's not a type of motion. It can go straight or a circle or back and forth.
Okay, let's just think about this question more. Okay, for question number 3. For question number 3, Shabab, for participant. Okay, Ryan.
A motion diagram is a series of images of a moving object that records its position after C. Equal time intervals.
After equal time intervals. This is a clear question. Okay, replacing number 4. Who will answer number 4? Faris Khalid Khattabi.
Yeah, Mr. Replacing an object in a motion diagram with a single point is called the particle model.
Particle what? Okay, thanks. Faris. Okay, number 5. Who knows number 5? Just wait 1 minute, Shabab, بس I'll take attendance. Okay, Shabab, back to the question. Who knows the answer of the last question, number 5? Manaf.
C, Mister.
The vector that represents the sum of two vectors is called
Resultant. C.
resultant. Okay, it's in math. The sum of any two things, we call it what? Resultant. Also, we'll use the same term in physics, and we'll know what is the meaning of vector. Okay, and the opposite word of vector is scalar. Inshallah, we'll talk about them, I think, next period. Okay, so we'll talk about vector and scalars. Okay, come to the first, I think, what question? Sumbul said it is dotted line. Okay. Okay, let us see, grade our test. Okay, thanks, Sambol. I think it was the hardest question in this today, and you have correctly answered 5 out of 5 questions. Thanks everyone, you did great for this session. Inshallah, we'll find this session, inshallah. You'll find the link on Wendigo if you want to watch the session again. Okay, thanks and have a nice day. Assalamu alaikum.